We are now going to talk about the pressure we place on two types of resources which are crucial for our economic activities. Fossil fuels to start with, and metals and minerals. But let's start with fossil fuels. So, the situation is a bit paradoxical. To a certain extent, we've already exercised huge pressure. And as for fossil fuel, if we look at climate at the same time, we have too much fossil fuel. But let's try and understand, and I'll give you a simplistic vision to help you understand the problem. Let's start with energy. As you all know, humans are not capable of producing energy. We're capable of capturing energy, transform it, transport it, and each of these operations has a cost in terms of energy. To capture energy, we need energy. To process energy, we need energy. To transport energy, we need energy. So the energy matter is a ratio to a certain extent. On the one hand, I look for energy and I use energy. So what's left of it? Let's take oil, because that's a very simple example. 40, 50 years ago, in most of oil fields, when I invested 1 barrel, I would get 100. It's the return, it's energy return on energy investment. So it's always a ratio, and you need to keep this in mind. Now, coming back to the matter of oil. Now we need to look for oil, and to do so we need energy. That's strict ROI, the energy I need to find, transport, process, has extended to other activities which are also energy consuming. So to a certain extent there is too much oil on the earth, and the International Panel of Experts on Climate asks humans to forget about this easily accessible oil and coal and leave it in the earth. So, and now we'll talk about the oil peak, even though it's not really an issue, but we may have ore peaks. So let's try and explain that in a very simple way. I'll use the image of a yogurt, and the spoon is a yogurt as well, and you will understand that when you start increasing, and once you've reached the yogurt, this is the half of the yogurt, this is when you collect most with your spoon, and the more you start operating the other half, you can imagine that at one stage it would be absurd if the spoon was made of yogurt itself. I would bring back less yogurt than what's in the spoon itself. That's the energy challenge, and it's also true for ore. So when you have a mine, whether it be fossil fuel or metals, at the beginning, when you operate this mine, you can increase the quantity you extract, and once you've reached half of it, we need to decrease the quantity either of energy, either of mineral that we are going to transport. And for a while we talked about the oil peak, and by this we meant that when we would reach half of the reserves, this time we would see our extraction capacities decrease. And this is actually what happened. If you look at what happened in the past, I invested 1 barrel and I obtained 100. And still looking at oil and conventional oil, on average, when you invest 1 barrel, you get 25 on average. And there again, we're just talking about easily extractable oil, conventional oil. In green, you have the graph for oil, and you see that as of 1964, the number of discoveries of oil fields has decreased, likewise for natural gas, with 15 years gap, roughly. And after 15 years, we see that the graph for the discovery of new gas fields is decreasing. And then when we approach half of the reserves, we face difficulties. And this is probably what happened, but we can't learn about the consequences that we learned for many years. We speculated a lot about the oil peak, but as a matter of fact, we have too much fossil fuel on Earth, and if we were to extract all of it, I think you understood we can't, but if we were to extract all of it, we'd have a 10 Celsius temperature increase on the planet, and this would be a disaster leading to the end of mankind. So we have too much fossil fuel, but we have yet another problem, i.e. the cost to extract this fossil fuel. It keeps increasing. The quantity of energy that we use as compared to the one that we mine is decreasing. If you look at shale sand in Alberta, the ratio is 1 to 5, and if I take into account infrastructures and transportation, at the end of the day, 1 barrel, I'm just investing just 1 barrel to get 5. It's 3 barrels that I need to invest to get 5. So that's a very small ratio. So that's an issue, even though we do not have to face the peak oil rate problem because we have too much fossil fuel. The quantity we can extract is no longer as it used to be, and it costs far more in terms of energy. And the energy we can use is far smaller than what we could use in the past. And that goes beyond oil. It's true for all types of energies. The more we move forward, the smaller the ROI, i.e. the quantity of energy. And if you look at wind power or photovoltaic solar energy, they're not as low as shale oil, but we're far from the historical results of oil. For wind power, technologies are mature nowadays, but for solar energy, we still have big margins ahead of us. At the moment, it's very difficult to calculate because the sun power is not regular, and according to the weather forecast, we're not going to get the same quantity of energy. But we talk about a return on investment of about 7 to 8, and we hope that in 15 years we'll achieve 15, and in 30 years' time we should get at a stable level of 30. And there we would have a very correct quality of energy, but not with the same quantity and level of increase in extraction as what we experienced with the beginning of oil. So, on and all, with energy, we're talking about a decreasing slope, and we've probably had the best of it. We are not talking about a world with no energy in the future, but we have to come to terms with the fact that there will probably be less energy in the future. As for metals, it's the same thing. It does cost energy to mine for all metals apart from iron. According to thermodynamics principle, metals should be homogeneously located on the crust, but thank God, for various reasons, including bacterial reasons, there are concentrations on the surface of the Earth, and thanks to that we invented metallurgy. So thank God for that. There are locations on the Earth where there is a higher concentration in ore. Therefore, the energy we have to spend is less. We excavate less, and on the other hand, the more metal is concentrated in an ore, the less we have to remove soil. But the lower the concentration level, and then we need to dig, to excavate deep and use a lot of energy. At the moment, we use 10% primary energy produced in the world for mineral extraction purposes. If we were to mine for copper, and if we were to produce the 16 million tons we produce each year at a very high dispersion level, it's all the energy produced in the world that we need to spend. So there is a limit here. It's not an easy limit. We can't point a finger at it for each metal, but we see that the trend of increased energy use is true. For some metals, we have to mine them 600 meters beneath the surface, and we won't be able to do that for all metals. And some metals, which are very important today for high tech, everything that helps us consume less energy, these metals are byproducts. We can't mine for them, but we mine for them because we mine for other metals. So this is a rather tricky situation, a bit like for energy or for fish resources or for other resources. We raided on these resources, and now we've reached some limits. And these limits are not easy, and they include many factors: depth, less concentration, required energy to find and then process these minerals. So we see that because of this increasing scarcity, increasing cost of our mining activities, we see the interest, opportunity, and need to have a more circular economy, because at one stage we'll come to the end of the road. And if I were to give you an illustration, and looking at all global resources, with a 2% increase in the way we consume resources, we could last for 100 years on a virgin planet with a stable population, which is not the case. And to look at what Gabriel Chardin calculated, after 5,000 to 6,000 years, still with this growth rates, in 5,000 or 6,000 years, we would have devastated, totally destroyed the universe around us with a 10 billion light years radius, which is quite a lot. So yes, circular economy is a requirement, not for the future, but for now.